So now we're going to take this linear tables thing and go a little further with it. This one says complete the table so that it is linear. Let's think about what that's asking. There are numbers missing here, x's and y values, and we need to make this so that the table is linear. Well, what does it mean to be linear? That's a question that we have to ask ourselves, and that's a question we've been asking ourselves all week. What does it mean to be linear? That means we have to have a constant rate of change. The rate of change has to be constant no matter what the intervals. No matter the intervals. So, the first thing we should do is see if we can figure out what the rate of change is so that we can then try and make it constant throughout this table. Well, what do we need for that? We need 2 points, x1, y1, and x2, y2. So where are those? Let's see, I've got a point here, and I've got a point here. So these guys will be my 2's, and these guys will be my 1's. So let's figure out the rate of change here. So y2 minus y1, 10 minus -5. x2 minus x1, so I've got 5 minus 2. 5 minus 2. So my rate of change, 10 minus -5 is 15. Minus a negative, 15. 5 minus 2 is 3. 15 divided by 3, that is 5. So my rate of change is 5 for every 1. 5 changes in x, or 5 changes in y, excuse me, for every 1 change in x. So, if I go 1 change in x here, that means I've got to go 5 changes in y. So 1 change in x means 5 changes in y. So 5 changes in y positive is from -5 to 0. That's my answer there, 0. If I went 1 step, I've got to go 5. Well, this time it doesn't tell me what my jump is here, but I do see that I'm going from 0 to 5. That's plus 5, and if I changed 5 in y, then I have to change 1 in x. There we go. Here's 1, so you'll see it again. From 4 to 5 is plus 1, from 5 to 10 is plus 5. There's a 5 over 1 change again. And again here I've got plus 1. So of course I need plus 5 down here, so 15. And there you go, now my table is complete, and this is a linear table. Every 1 step in x gives me 5 steps in y. That was an easy one. Let's look at one that's a little bit harder. Okay, this one's just a tad bit harder, but we do it the same way. The important part, it says complete it so that it's linear, so that means we have to have a constant rate of change. The rate of change needs to be the same. What is the rate of change? Well, let's look. y2 minus y1 over x2 minus x1. Let's pick these guys. So here's my 1's, here's my 2's. And 3 minus -3 for y. 3 minus -3. And my x is 7 minus 3. So 3 minus -3 is a 6. 7 minus 3 is 4. This simplifies to 3 halves. So this means every 3 changes in y, I get 2 changes in x. And vice versa. For every 2 changes in x, I get 3 changes in y. So this is a little bit more difficult because we're going to have to go backwards here. And it looks like these steps aren't exactly all the same. So here's where we really have to do some thinking. Let's look at this jump. This is plus 6, and this is my x's. So if my change in y over change in x is 3 halves, that means every time I go 2 for x's, I have to go 3 for y. So how many times did I go 2 here? To get to 6, I've got to go 3 times. So that means for y, I've got to go 3 times as well. So think about that. Since my change in x is 2, and I went 6 here, that means I did it 3 times. So my change in y is 3, so I've got to do that 3 times as well. So when I finish here, I'm going to get 3, and then plus 3 is 6, plus 3 is 9, plus 3 is 12. All right, from 12 to 18 is plus 6. Well, that's my change in y. If my change in y is 3 and I went 6, that means I did it twice. 3 plus 3. Which means up here in my change of x, I need to do that twice. 2 plus 2. Because I went 2 for 3, 2 for 3. Same here, I just did it 3 times. So 13 plus 2 is 15, plus 2 is 17. Here we got to go backwards. That can be a little confusing as well, so let's look at that. From here to here, I went plus 2. And that's my regular change in x. So that means from here to here had to be plus 3. This is my regular slope. So if I needed to add 3 to get to negative 3, that means I need to subtract 3 to get back to here. Negative 3 minus 3, we're at negative 6. We're going more negative. So now this table is linear. 1 and 6, 3, negative 3, 7 and 3, 13 and 12, 17 and 18. Because I just found my change in y over change in x. This is my rate of change. And it needs to be constant. It needs to be constant throughout this entire thing. And that's why I had to kind of take these intervals. You'll notice each one of these intervals here is 2 for every 3, 2 for every 3, 2 for every 3. Sometimes I have to just do it more than once to get to where I need to be. This time I had to do it twice. This time I only had to do it once, but I was going in the opposite direction. So make sure that you find your rate of change, and then you follow that rate of change all the way throughout the table in order to get to where you need to go.